We're really excited to be hosting another webinar talking about a topic that I know is front and center on everyone's mind. This is an exciting session today. We welcome all of you that have joined, and those of you that are watching it on video after the fact. I'm sure you're going to get a lot of ton of value out of this. And I just want to start off by just explaining that this is going to be just a moderated discussion. We're not going to have slides. There's not going to be a demo or a sales pitch or anything like that. What this really is going to be focused on is spending the hour talking through ideas, experiences, and what we're seeing in the real world. So we want people to drop in questions in the Q&A, and we'll leave time at the end to go through as many of those as we can. And so I guess just to get started, one of the questions is, why are we doing this webinar? And I just want to be very clear that we're hosting this. It's really kind of our opportunity to share with the world what we've been seeing and experiencing, because we're right down in the center of everything that's going on with the topics that we're going to be talking about today. OpsCanvas, over the last year, we've spent a lot of time talking with operators, platform teams, customers, partners, all about kind of what's happening, how AI is changing cloud operations. It's obviously changing a lot of aspects of all of our work, but specifically, we're going to talk about cloud operations. And internally, we've been doing a lot of work, not only to synthesize a lot of these ideas into our products and our offerings to support our customers, but we've really had to figure out a lot of these just in the practice of how we do things. Just as a word of note, OpsCanvas, for those of you that are new to understanding and getting to know OpsCanvas, we are a platform that really leverages AI and incorporates AI in a native way to help organizations manage their cloud. So everything from managing your expenses, how much your cloud bill is, where's the waste, what am I spending my money on, all the way through to understanding what's happening, why did certain things change, and getting to answers quickly that AI can now do so much better. And so, today is us sharing a lot that we've learned in building a product that obviously is very central to this. And this is really going to be a conversation about research. And so I want to, get started by talking about something that's been very consistent in those conversations. Most teams can see what's happening in their cloud environments. They might have some dashboards. They've got their logs. Everyone knows how to get around and find different reports they need or, security findings. But what's still hard for just about everyone that you talk to, and it's surprisingly hard, is actually explaining why. Why does something exist? Who owns this? What's safe to change? And all the sort of questions that really you need to make good decisions, which wind up requiring a lot of effort to figure out. And so that gap really slows down these decisions. We're all inherently in the world of cloud operations risk averse. So we don't want to do something that's going to create a problem. And so we wind up obviously getting into the details, doing a lot of manual investigation. But as environments scale, as organizations are dealing with larger and larger workloads in the cloud, the problem doesn't get smaller, it actually compounds. And so in our last webinar, for all of you that enjoyed that, we had an incredible turnout and interest in that. We talked about how are you preparing for AI and CloudOps. And so a lot of the discussion was about co-pilots and agents and automation, things that we all kind of know a little bit about or sometimes a lot about. But the conversation that we had kept coming back to something a lot more fundamental. AI runs into the same problem that humans do. So we can kind of see the state of things, but we don't actually know the intent. We don't understand why it's there, as I was just referring to earlier. And so this conversation is really continuing that and really digging into what this focus of this intent, which is context. And what do we mean by context? Why is it missing today? And how is this new term that's been out there now the last few months that you see organizations and AI companies and investors talking about all the time called context graphs? How does that help create the foundation or add to the foundation that AI needs to operate reliably in cloud operations. So before we go into deeper technical pieces, we're going to spend some time grounding the problem, defining the terms, and we want to start all at the same place. We know everyone's got a different level of understandings of some of these things. So we're gonna really start there, and then we'll go a little bit deeper as we get into the conversation. So first off, I'm gonna introduce Jason Turim. He's the co-founder of OpsCanvas and CTO. Jason has spent his career building and operating cloud platforms at scale. And he spent a lot of time thinking about why cloud environments are so hard to reason about, not just technically, but operationally. So a lot of the ideas that we'll be discussing today around context and context graphs come from that work. And in fact, Jason just recently wrote a white paper that we referred to on the last webinar that really crystallized the opportunity and the challenge that this all represents. And so, Jason, I'm going to turn over to you. Just if you could give me a sentence or two on, what part of the decision making within cloud operations do you find most broken today?
Yeah, thanks, Brian. Hi, everyone. It's great to be doing this. I just want I guess, in a sentence, I would say that CloudOps today is really focused around resources in the cloud, that is the individual services that we're using, but operators are making decisions about software systems. And how do you bridge that gap between the punch list of individual services that you might show up in alerts or anomaly reports and the operator's mental model of the software that they're running?
That's great. Well, it's going to be exciting to kind of dig into that in a lot more detail. And joining you, I'd like to introduce Ardhendu. Tripathy he's the lead AI engineer at OpsCanvas, and we affectionately call Ardhendu Ardy. So Ardy, welcome. And Ardy's he has a PhD in computer engineering. He's published research on using LLMs and neural networks more effectively, and really the problems caused by AI making decisions that have real cost, security, and reliability considerations is something that he's been intimately working on every day at OpsCanvas. Ardy brings a practitioner and an engineer's perspective to what breaks with AI, particularly when context is missing and how to fix it. So, Ardy, I'm going to turn it to you, and I'm curious to know, where do you most often see teams losing context as environments grow?
Yeah, hi. Thank you for having me here. And yeah, it's great pleasure to be talking about all this exciting stuff. So missing context is always, in my view, it has always been between the seams. So it can be between different teams, it can be between different systems, it can be between the mental model a person has when they are writing a piece of software versus when they are reviewing it or debugging it later. And so anywhere where you have information that needs to be analyzed and acted upon, and you are missing some pieces, like I'm sure we'll get to it in a bit more detail, but you're missing pieces such as why something is set up the way it is, then anytime you need to make a change, or I want to do anything, I need to repiece that together in my head to make sure that I'm still aligned with what was there previously. So yeah, that's like one place. And the same thing works for AI. So humans missing context and AI missing context are gonna give you the same type of results, which are not great.
That's great. I love that visual kind of way to think about it, is in the seams. That makes all the sense in the world. And obviously, in organizations, there's a lot of different scenes. So I'm really going to be interested in digging into that a little bit more. And I'm Brian Kathman. I'm co-founder and CEO of OpsCanvas. As you probably can imagine, I spend most of my time talking with customers and operators and partners about how cloud operations is changing. And we're just seeing this sort of evolution or speeding up of AI being part of the conversation in ways that we've actually seen recently within software engineering and coding. The way Claude Code and those coding tools or agents for using AI have really taken hold and accelerated significantly in the last year. And we feel like we're on the precipice right now of that happening within cloud operations. Maybe not next month, but certainly we're going to see a lot of shifting and changing in this world in the next year. And so it's exciting to kind of get out in front of it, think about some of the challenges that we're going to talk about. And so before we talk about AI or context graphs, I want to ground this in something very real. So I think we all kind of know that cloud operations is not suffering from lack of tools. In fact, I think that we have maybe too many tools in some cases. It's one of the challenges, this kind of the number of tools that an organization not only has, but that a team or an individual has to learn can create a lot of switching of context, using the word of the day. But it really has application for very specific point reasons: observability, cost management, security, CI/CD, inventory, tagging. There's all sorts of different ways in which these tools are used in their own particular unique way. Yet the decisions that are being made are oftentimes still very slow, feel very risky, and in a lot of ways, with all the technology around us, surprisingly manual effort involved. And so teams can usually tell you what is happening in their environment, like I was saying earlier, but it's much harder to answer questions like, why does this resource exist? Who owns this environment over here? Because I got a question about it. I want to change something. What decision led to the database going down? If it was, in fact, a decision, maybe it was an event that happened. What breaks if I decide to change part of my environment? And so the answers to those questions don't just show up cleanly in a dashboard or something. The answers to those questions, they oftentimes live within our experts, our team members, maybe across systems, tickets, documents and documentation, maybe even Slack threads. So that gap is really between seeing what the state of something and understanding the meaning of why it is there is a problem that is, really challenging. And so we're going to take a few minutes unpacking that. So, Jason, I'm going to turn to you first. And in your companies, including, building OpsCanvas and talking with teams, where did you consistently see the cloud operations, whether it be DevOps or FinOps or just governance, break down? Even in those organizations, I know you've worked from some really large organizations as well that have more mature tooling. Where have you seen that breaking down most often?
Yeah, I mean, answering the questions that you sort of went over, I think, is the core issue here. And when alerts fire, when your dashboard starts showing red, these are the questions that you have to answer. And it often takes going back to almost like first principles to reconstruct the context of a resource or an issue or the state of a system and why it is. So, and that happens if you have more tooling, you might reduce the amount of time it takes, or it's unintuitive, but might end up taking longer. Oh, I have more tools to check. I have more signals to cross-reference, and that ends up adding time to an investigation where the intuition is, I have all of these signals available to me. Why can't I just find these answers quickly? And so you have these tools that are telling you that resources aren't behaving within, their expected operational parameters. And when it comes time to fix it, you sort of have to go back and investigate from the beginning. And then often what happens, either or, oftentimes, despite all these tools, you're going to look for the person that in the organization that has the answers. There's typically somebody who is able to look at an ARN and associate it with a environment or a workload. That might be extreme, but point being that, some folks on a team have this incredible depth of knowledge, and it's certainly not everybody on the team, and it's certainly not everybody on the team for any possible alert. So a lot of the frustration happens because you're constantly investigating, sort of from going back to the beginning to piece everything together. You feel like you have to find this person who knows, who you think might know what they, might have the answer. And the whole thing just feels, I guess, sort of shaky for like these we're high tech, we should have answers, these answers should be presenting themselves, and when the rubber meets the road they're sort of not. And so I think one of the challenges, and as we talk about what context can bring, and how agents and humans as well will be able to incorporate that into their work stream, is that providing the missing information that the current state of the system doesn't really capture. And I'm still surprised by it. I mean, every time you're sort of presented with it, you're like, oh, I have to go back, I have to look this up. Like I don't just have that information that's not available, especially if the fix is obvious. Why do I even have to be doing anything here? Why can't the machine just take care of itself? So I think there's a lot that's still quite surprising when addressing anomalies. And I think that intuition of, well, why does this stuff that seems like it should be simple so complicated, just in general? I think that proliferates through the CloudOps stack.
Great. And I've got a follow-up question, and I don't think it's going to require as long of an answer, but what how often do you feel like in this the sort of the the owner of the truth, this individual that knows everything, how often are you able to make a decision without checking with them first? Like, is it half the time, most of the time, just a few random cases where you wouldn't, or is it you're almost always checking with them?
No, I think it's pretty situational. If it's largely depends on your confidence of your own understanding of a problem. So maybe say, I'm really hands-on and involved. So personally, I'm going to put that at 75%. I feel comfortable I can handle it, but also I'm ultimately accountable. So it's maybe a little different for me as a CTO than someone who's on the ground as a IC making big decisions.
You might be that guy. I
I
mean,
might be that guy. Yeah.
so so then, I mean, I guess one other question that I think I'm sure that we've got people from really large organizations that are watching this, as well as from startups. I mean, the problem that you just described is fascinating, and I think everyone can relate to it. But is it different if I'm on a 5 or 10 person team versus if I'm on a 50 or 100 or 500 person team? Like, what's the differences based on kind of how large the organization is, or are there differences?
Well, there are definitely differences. Certainly, tool maturity is a big difference. So typically, if you're in a 500-person team, you have people that are responsible specifically for an alert, putting up, your observability stack, and the ownership around these different systems is a lot more clearly defined, which in some regards makes it easier to find maybe a person that you're looking for because you have ownership boundaries, but also in a very big team, you don't know anybody. Like in a small team, you just know, oh, hey, it's Ardy. Ask him. I can ask Ardy. I have his mobile. I can send him a text. But in a larger team, that those avenues might not be open to you. And then also sort of what I alluded to earlier, with more teams, with more tools rather, you run into this correlation problem where, okay, well, I see this in my AWS, I see this in CloudWatch. Okay, I can see this in Observa in Datadog, and then I have to go to my 6 other systems to correlate. And maybe in smaller teams, just the CloudWatch is enough for me to make a decision, or for me to huddle up with someone on my team to make that decision, and we might be able to get to an answer quicker. I mean, definitely. I mean, it definitely I mean, more process always introduces, slows things down. So the balance is always rapid response versus an assuredness of the
Right.
response. Yeah.
No, that's great. And I'm curious, and Artie, I'm going to turn over to you. I mean, I know you're, I don't want to say that you're not the guy. Like pointed that Jason might be the guy that kind of knows more than
I'll
the
point
rest
to
of the
Ardy.
team that they're all coming to. But let's just kind of think about it from your experience
Sure.
and a lot of the AI research and that you've done and the work that you've done with different customers and organizations. Where do you see these problems actually show up? I mean, I hear what Jason's saying, but where do they show up and where is it most painful as organizations are kind of trying to scale or trying to kind of get their arm around this problem?
Yeah. So like the problem in cloud operations, Jason alluded to tool proliferation. I mean, there's also like a saying that nature abhors a vacuum and production abhors a singleton. So you have config explosion. Like if you have many environments, they're all going to be set up certainly differently. They're all probably have different versions of their constituent services running. And so really understanding, well, why something is breaking and why something else is fine, like it gets hard because at some level you're trying to make a comparison, like a pairwise comparison. And with more environments, it just scales quadratically. Like, with n, you have to make n squared comparisons, so to speak. And so at some point, it's just not humanly possible to have all of that in your brain while you're under pressure or you're trying to make some decision or you need to fix something. And so that config explosion is a thing. Everything is certainly different. Yes, you can go look through the source code, comb through the config map and whatnot. But then, each there's a like a chain of steps and each can introduce issues, right? And when you have multiple things which are different between environments, like how do you attribute, the thing to what was the cause? And so that's just the nature of modern cloud ops. I feel like things get more complicated, and when you have complicated things, you always get this hesitation of, oh, don't touch it, right? Because um, you're not sure about why this was there or this was set up in this particular way at the beginning, right? And so before you even go ahead and make any change, you want to make sure that you're not causing some new issues, right? Like
Yeah.
suppose you put all it together and then, well, I think it's good. Maybe I'll go ahead and do it. But what if it's not? How many systems are going to break down because of that, right? And if I can't accurately make that determination, then, I will either not do it, it'll reduce my velocity needlessly, or maybe I will just ship and hope, which I hope not, right, and then cause some issue. So yeah.
That yeah, that never happens though, right?
Yeah.
So so yeah, I mean, like I feel like you're describing a day in the life of a software engineer,
Yeah.
DevOps engineer, an SRE, or everyone kind of has to wrestle with that. And so, I mean, I think we all understand the problem. And you guys are both using the word context here and there, right?
Mhm.
And the purpose of this webinar is really to dig in on context graphs. So I want to use this opportunity to really slow everything down and kind of reset a little bit on what is context, because I think we've got a lot of different ways in which we use context, and especially when we're talking about AI. And so if we're not careful, we can start to use it for everything. So I want to turn this back to you, Jason, and
Mhm.
can you give me a sense, like when we say context and within cloud operations, as you and Artie are talking about it,
Mhm.
what are we really talking about? But don't say it with buzzwords. Try and say it like as if you're talking to, a grandparent. Like how would you describe context? And you can go a little bit deeper than the grandparent if you need to as well.
Yeah, I mean, at its core, I sort of think about context as institutional knowledge. So what we talked about the one person on your team that you go to for answers. What
Right.
do they have that someone else on your team may not have? And what they have is they just keep a whole bunch of stuff in their head. and they're able to reference it. And to me, that's the context, and that's the context that's particularly important when you're firefighting issues, because you need to have a systems understanding, you need to have sort of the operational understanding, and architectural, where does the piece I'm working on fit into the system as a whole, and you need to be able to recall all of that information quickly, and you need to be confident in your assessment. And all of those things, munge them together, becomes context. I think of it also as ambient knowledge, institutional knowledge, but it's missing. I mean, and I don't want to just drone on, but I think we're not missing signals in CloudOps today. We have plenty of data points. And what's missing in CloudOps is, how do you stitch them together to make sense, to be recalled, to act on, and to be confident in the action that you will ultimately take. So that's how I.
No, that it's great. And I have a kind of follow on to that, which is, and I'm going to go a little bit deeper on this, but I'm just kind of, what you described makes a ton of sense as you lay it out. Like, there's this institutional knowledge. I mean, I think that happens in a lot of different teams, right? You've got
Hmm.
sales team, there's institutional knowledge of how you're going to win over a customer in this situation, right?
Hmm.
Or
Hmm.
there's, a sense from finance, they just kind of know how you're going to close the books on this type of transaction.
Intuition.
And intuition, there's a lot of elements to it, but like, we think about software engineering, and cloud is running software. So, it's the operations of that software running in the cloud. It feels like everything's software. So why, like, how did we get here? Why is there this institutional knowledge that's not showing up uh, in a system on a dashboard? Like, it seems like, did we design things wrong, or is it there because we just kind of haven't advanced enough yet as as technologists and companies?
Well, I mean, my feeling is that, I mean, computer science and the software industry is a story of standing on the shoulders of giants. So, and layers of abstraction, right? So you're always building on what comes before. So, the fact that a phrase I love is, we've taught sand to think. That's the CPU silicon, right? So
Right.
we've come so far. So, for you don't know what you don't know. And capturing data and being able to capture metrics and thresholds and operational parameters, that has always seemed like the most important. And it's not till you've been working with that for a while that the shortcomings of what was so great, a year ago or 2 years ago or whatever, really starts to present itself. And it presents itself in such a big way as this wave of AI comes crashing down over everything, because that was just the way we did things, because that's how we did it, and we could capturing data, and now we have managed data centers and capturing signals, and this whole idea of having essentially actually thinking machine to be able to process all of the signals at once is really pretty relatively new in industry, at any rate. I mean, I think it's been in academia for a while, but like, the practical applications are just kind of presenting themselves and just coming to the market now. So I think that it's really a combination of all of that is why we are sort of where we are. It's not like, I don't think
Yeah.
it's any it's not damning the industry or anything. It's just a natural progression.
Yeah. I mean, it's fascinating because as you're describing that, and I don't want to get ahead of ourselves here and give away too much, but as you're describing that and kind of just the nature of things, it's almost like the potential and opportunity that AI presents is forcing us to think about things that we hadn't had to solve before, right? When you think about, I
Yeah,
mean, I think
totally.
everyone kind of knows that the cloud has its warts and has its challenges and has its blind spots and all the things that everyone that works in the industry knows. But we haven't really had to go and try and solve it as long as we could get by, as long as we could, duct tape things together, and it wasn't breaking, and we got, we could start to bring the bill down. But it feels like what you're saying is that it's kind of we're now forcing that. So that question because of AI. And so and we're going to get to kind of how this all ties into AI certainly in a minute. But I want to go back to you, Jason, just follow on question in the sense of like, so you're describing a lot of this institutional memory as like living in people's heads, or maybe it's in a Slack,
Yeah,
back
yeah.
and forth, or maybe it's, some tickets, but it's not organized in in a structured way. It may be kind of just written out in a paragraph or whatever. So how do we make that this this institutional memory that you were describing become usable?
Well, I mean this is the idea, the concept behind the context graph. So the idea is how do you encode sort of these signals, these five W's is how we think of it internally, the who, what, where, why, and when of action of meet important actions that generated a signal. So we know that a CPU is pegged, but what we need to know is sort of the step before that, and maybe, well, why is that VM even running? Why is that instance even running? Why was it configured to be a certain instance size? And how do you capture all of the attendant information around, like, we know that there's a VM running and we know that its CPU is spiking, but there's a whole bunch of who, what, why, where, when questions that led to this moment in time. And
Mm-hmm.
just going back to what I was saying before, I think is that we were computationally constrained. I mean, the limits that we have now on storage on CPU that is so much further than it was 2, 5, 10, 15 years ago, that it makes answering the next question easier because we have more sort of tools to do it with, resources at a basic level.
So the context graph, I kind of understand what you're saying is it's a way for software to organize institutional memory in a way that both humans and AI agents can use to make decisions and reason over. But how is that different from just tagging a bunch of things or looking at a log of activities? Like why is this graph so critical and different than kind of the old way of maybe capturing some of this information?
Yeah, I mean, I think there's a few things that sort of make this a different. I really think, not to repeat myself too much, is that the actual data being captured is a huge distinguishing factor. Instead of capturing this whole concept to capture the reason behind the action is like a sea change in thinking, and it's a very important one in agents. I'm sure everyone listening has experience where if you've run multiple agents and you ask them the same question multiple times, they'll come to different conclusions because they have a different context in their memory. And so being able to centralize and provide decision making on a firm baseline understanding of a situation will help combat sort of the non-determinism that's inherent to the LLMs today. And so I think that those combined are what make it so important. Maybe Artie, you have some ideas on this.
Yeah, yeah. No, I mean, going back to the question like why now and how AI and I mean the big thing, as Jason pointed out, is that the capability of processing or reasoning over natural language is what is new right now. So and Jason put this in his white paper as well about knowledge graphs and how context graph can trace their lineage back to the area of knowledge graphs and semantic web. But I mean, we didn't have LLMs right back then to be able to, read everything. Everything in the semantic web, everything had to be perfectly tagged, had to follow a schema and so on. But now with LLMs, you don't need that perfect schema. You can infer tags, if you want to call them tags, or you can infer the reason, the who, what, why, when, right? those questions. You can infer those from natural language text. And if you think about it, software till today, I mean, obviously humans are making it. And so humans would communicate with each other in natural language or write down their thoughts, documentation, whatever, right? And so that was kind of like the human part of it. And the software was the end product. But now with agents, when agents are writing more and more of that end product, you kind of have to give them more reasoning behind why that software ended up being that way. And so previously, somebody would have to construct a whole knowledge graph, enumerate all possibilities, annotate them, make sure it's correct, make sure it's not contradictory. LLMs just supercharge that process today. So yeah.
That's fascinating. So I think it makes a lot of sense that the capabilities of LLMs to basically infer these elements, the institutional knowledge that previously wasn't being captured is that's the breakthrough, right? Like now we can actually, as long as we're there in the moment of knowing kind of what's going on to be able to infer the why or infer, what exactly happened, then, the LLMs or the agent in this case would be able to kind of infer that. Whereas I think previously the guy that had all the institutional knowledge, he's not writing it down. And even if he is, it's not somewhere that everyone else has access to, right? And so I think what you're saying, and I kind of get this visual in my head, and I don't know if this is the right way of thinking about it, but it's almost like now because of AI and because of the agents, as long as we're designing the system to make sure that we have an agent that's kind of, on the guy's shoulder or anyone in the organization's shoulder while things are happening, they can kind of document it without the human having to document that and capture that. Is that the right way to think about it?
Yeah, it's a great. I think so.
Yeah.
I mean, that's largely, and when we're talking about it internally, we talk about deploying recorders to capture facts that are happening as they're happening. So how do we see something happen, make a decision, is this worth capturing or not worth capturing? If so, sort of stamp it and save it, and then make it available to be reasoned over later. And so very much sort of the model that you just described of the watcher. And just to add the documentation, if our hypothetical superstar is documenting, often that documentation gets out of date quickly.
Right.
And so having time-based decision traces, which are one way that we're sort of thinking about what make up a context graph, is a series of sort of points in time decisions that are happening as work happens. Naturally, the more recent decisions are taking precedence over the earlier decisions. And so it naturally weights, which is something that is completely missing when you're just having like someone on your team maintain a wiki or whatever. And not to mention all the attendant, there's a million problems with that model. When it works, it's great, but there's a million problems with it. But the biggest one is that it's often out of date like a minute later.
And I wish, Jason, you would have provided that answer to me like at the very beginning, because the term superstar is so much better than the guy. I don't know why I didn't think of that. So let's call it the superstar. So the superstar, and everyone's a superstar because ultimately the agent's going to want to understand decisions that everyone's making.
Sure.
But there's a superstar that might have an inordinate amount of that sort of institutional knowledge than everyone else. So you're starting to capture that. But I think this brings us around to a really important question. And Ardy, like you're really deep into this utilization of the context graph, right? And so I want to understand, or I think the audience would really want to understand. So what actually changes then when we have this context, right? And the context is now part of the decision process or part of the system knowledge for decision processes. Like what then changes? How does this change everything for us?
So, so if you think of context and context graph, or however you want to name it, as the institutional knowledge, then any and every agent should be able to tap into it, and so that it can, get the right piece of information and come at the right decision to take. So the context needs to be searchable, easily queryable, and it also, I mean, context graph, people working in AI and LLMs always talk about context window. And so yes, our compute is improving constantly, but at the end of the day, when you look at the architecture of LLMs, they have a fixed context window size. And I'm sure everyone has noticed this when their chats get longer and longer and it suddenly drops 20 IQ points, or so you feel. And but that's essentially the fact that it by way of its architecture, it cannot attend to things or tokens which are larger or beyond its context window. And so at that point, it becomes really critical. At that point, yes, we have a lot of compute, but for a particular agent that is given a particular task, it doesn't need to know the Bible. It just needs the required pieces of information that will fit in its context window and let it breathe. It has its scratch pad space so that it can reason through it and then come at a decision or take an action.
That is exactly the opposite of the way I think a lot of people think about AI, right? So a lot of times when we think of the power of AI or ChatGPT and LLMs, it's that now the information of the world is at our fingertips and it can answer any question. But what you just described is so critical to and important to why context graphs are so valuable. It's really what you're saying is, you know, context isn't about more data, it's about more meaning behind the data. So if you can focus the data that you're trying to get meaning around, then you're going to get a much better answer. So, like the context graphs, if I understand as you're describing it, are a way of making that meaning much more explicit and clear by, based on specific resources or, decisions around a particular situation, as opposed to looking at every situation that ever happened in my cloud. I'm never going to be able to figure out what's the right decision. But if I know these are the 10 pieces of data that are important, then I'm going to get an answer that's very relevant in context for that.
Absolutely. Yeah.
So that's I mean that's it kind of turns everything on its head. So what you're really, Ardy, what you're getting at is that the context graph really is about making AI and agents smarter and more reliable by using less data.
Yeah, using the right kind of data.
Right.
LLMs, like if you feed in a several different things which are contradictory, they're gonna pick on the one which they think is most out of the average, right? And so they can latch on to patterns which are not relevant for your particular task, and they can get misled. So yeah, so having the right piece of information and providing it to the LLM, it gives it a significant boost so that it can actually achieve that objective.
So this kind of takes us over to kind of it's a great transition to the notion of why don't I just point an LLM at my cloud and I'm going to get the answers I need. But I think you were just making the argument that is going to come with its risks because it doesn't really have the context. And so I want to kind of get into why we can't just do that. And on the surface, it sounds reasonable that we have all these data points. It's kind of like our raw material to make a decision, but that we don't necessarily always have the right or all of the raw material, all of the data points to make a decision. So I guess maybe Jason, turning back to you, why, from your perspective, and I'm sure you've done it, but why do you feel like the leveraging context in the context graph is better than just pointing an LLM at the data and hoping that you're going to get the right answer?
Yeah, well, for sure. It's I mean, we've seen internally that it's apples and oranges. You point it, and just what you said. If I point anything, a LLM or a human, at a laundry list of database names and ask them to figure out what's wrong, they're gonna just have to go digging. And what digging means is I'm gonna have to look at CloudWatch alarms, then I have to go look in maybe a Git repository to try to find some IAC that touched it. And then that might lead me to another Git repository that required a change to the IAC. And these are precisely the kinds of who, what, where, why, these decision trace actions that get captured during the context. So did a deployment happen? Did what changed in that deployment? Or what's the commit hash of that deployment? And now you start to paint a causal chain that an LLM can reason over. So I can see, well, there's a commit that changed the database configuration, and that's the database that's now the alarm is firing on. And without it, an LLM might not even have access to these systems. So there's just a lot of like mechanical stuff that needs to happen when you couldn't just get all the answers out of the cloud. So pointing an LLM just at the cloud wouldn't work. You'd still have to do all the wire up to get the other attendant information that humans would need to sort of solve the same thing. And the context graph and decision traces are the way to sort of get that information in place at the appropriate time. So just to echo what we've been saying up until now, it's about
Hmm.
getting the right data to the right agent at the right time, no more, no less than it needs. And that's incredibly similar to how humans operate. It's just now we have to codify it, and we have to think about what does codifying it mean, and what are the mechanisms for doing that. And that's what a lot of the work is about.
And maybe I'm going to take a minute and shift over. We have a long list of questions that are coming in. I'm going to grab a few of them here in a second. We only have about 10 minutes left, but before I do, I just want to kind of highlight one thing that I think we kind of breezed over, but it's an important element here, which is that what we're talking about with context graphs is not um, more data, but we're talking about really interconnecting the data elements that already exist and adding some, capability around that to know what data is important to make a decision or answer a question. Is that the right way to think about that?
Yes, I think so.
Okay. I just wanted to make sure that we're all because this next question starts to go in that direction, I think a little bit. The question that came in says, this all sounds great when your telemetry tool works and you want to use AI to get to the solutions it surfaces. What about when telemetry fails and you're just SSHing in and poking around to find out what's wrong?
Artie, do you have any thoughts on that?
I mean, SSHing, yeah. So you presumably when you're trying to solve the problem, you are taking the help of an AI agent as well. And so um, if you obviously it comes into some type of like, okay, obviously you don't want to SSH into your prod server and let it read free. But if you have the correct guardrails in place, it can do the SSHing for you. It can find the correct commands and give you the data that it needs and make an analysis of it. So yeah, Jason, you want to add to it something?
Yeah, I mean, I would say it's really analogous to how human operators work. I mean, what happens if your observability stack is down when, what you're looking for, trying to research a CloudWatch alarm, and then it just turns out that like, your collector process, um, borked when it right at the time you need, and so what do you do in that case? I think in an agentic sort of future, that's when it should revert back to human control, because ultimately it's accountability that's going to be important as agents are doing work on behalf of operators. It's going to come back to trust and accountability. So what happens if a AI agent is running blind, well, it shouldn't run blind, and it should go. And that's when you kick back to humans who would have to do what, we've always done, which is just, kind of figure it out, get good, kind of thing. So, it's that's sort of a trial by fire time. And I don't think, and what would be very interesting in that scenario is with our little recorder on our shoulder, watching the human take these flying blind actions and then actually being able to reason over those actions sort of the next time this happens. And that's sort of the real power. And this actually goes back to something that we talked about, if I just have a minute to put this in there, is one of the things we talk about that's so different with context graphs and agents versus sort of traditional systems is being in the read path versus being in the write path. And like that's and the way we sort of I think about it, and I think the general thinking about this is that agents working off of a context graph will make decisions and then contribute back into the context graph. So they're reading the data and then contributing to the data set that they continue to reason over. Unlike traditional tools where, alert happens and that might get slurped up into Datadog, and then, a human goes and reads Datadog. So, Datadog is read path, whereas sort of this agentic context graph future, it's both read and write path. And I think that the question sort of illustrates the power of that model as well. But yeah, I mean, for sure, at the end of the day, I don't think anybody is ready to just say, let the agent figure it out. But who knows where the trust is going to be in 3-5 years. I would let my superstar just go figure it out, but I might not let my intern. And right now, that's what the agents are, interns, and who knows what they'll be in 5 years.
There was a lot there. I mean, just to summarize back, it was great.
Yeah.
And one is, the question originally was around if my telemetry fails. And I think that it goes back to this adage, like, AI is only as good as the data to some degree, right? Like it can certainly make better use of bad data if it can figure out how to make it good, but that's not a given either, right? And certainly missing data, the last thing you want is for it to make up and contribute and hallucinate, create data. But then you're also talking about just the idea when you're talking about an agent contributing back into the context graph, that really speaks to the fact that I think in the future where you have ops agents, cloud agents that are doing things and contributing, they're really part of the team at that point. You start to think of your team is growing with agents, and I think that's a really fascinating thing as well. But it all comes back to, yeah, when all else fails, I mean, you can't just rely completely on AI and agents if the system fails, if power goes out or whatever. The humans need to be involved, and I think the whole human in the loop mindset is certainly critical to all of this for sure.
Until the robots come and plug it back in. Yeah, yeah.
Right, exactly. So I have one more question that I'm gonna get to. Actually, I might have two more questions. One question, which I think we kind of covered this, but the LLMs are known to give different or even contradictory responses, even with the exact same context and prompt. So at what point are context graphs the solution rather than supplementing with deterministic workflows? So I think it's kind of this idea that maybe are context graphs really going to be able to be as accurate as a deterministic workflow?
For sure. I mean, it's a great question and an important one to think about, I think. I guess, internally we talk about a trust knob, and the way we think about this is that, it's a lot of the same stuff that we've already talked about. Having a human in the loop, I don't think anyone is ready to turn the keys to the castle over to the agents yet. And I think that you're right that there are cases. We talked about the case where different LLMs without context will produce different answers. And now you're saying, well, the valid point, well, even with the context, they might come to different conclusions. And I think that this is why it requires trust experimentation. I mean, a lot of the classic sort of sciencey stuff that we learn in school and whatnot, is that you have to test and validate and verify, and I don't think any of that stuff is going away. And it's just the experimentation. When Brian opened up and said it's going to change a lot in the next year, and it will, but it might be more on front loaded on the experimentation side and getting humans used to working with agents. If we think about agents as being team members, it's like, well, you got to get to know your team members and you got to get to know how they work. And I think that context graphs are based on our current understanding of capabilities and limitations, and then we'll get to the next level and we'll correct them, and it's going to be a rinse and repeat cycle like everything in computer sciences, and
Yeah.
we'll navigate through.
So I have one more question, and we're almost at the hour, but before I get to that, I just want to kind of button up, I think, where we're, going in terms of agents and trust and all of that. I think trust is foundational. And what I heard kind of reading between the lines is that no matter what, you're going to have governance, you're going to have auditability, you're going to have verification, human approvals, workflows. All those things are going to have to be part of it, right? And
Sure.
so I think that that's a really important point, is that it's not like the dawn of uh, agents in CloudOps removes all these other things that have been taking a lot of time to build up.
Correct.
Uh,
Yeah.
so my last question is, and this is kind of just something that I had experienced, but I'm curious to get your either or both of your thoughts. You're starting to see some posts now on LinkedIn where they're going a little bit viral because people are pointing Claude Code at their, AWS account or their GCP account or whatever to try and identify waste or to do, lower costs and all that kind of stuff. It's really it's getting a lot of visibility because it's, oh yeah, of course, let's do that, which all sounds great. But I guess we just went through this whole conversation about why that can be not as accurate as with if you have a context graph, and just generally speaking, why an LLM may not have all the understanding or whatever. So I guess the question is, what do you think actually goes into getting Claude Code to work? Like what is it that would make Claude Code the best ops agent in the world, and what would be required to make that happen?
Um, well, I mean, they themselves, Anthropic themselves, are providing extensibility points to enhance Claude Code and make it allow you to specialize it. So I mean, that's part of it.
Well, let's take a step back. Let's
Yeah,
think
yeah,
like
yeah.
an organization like OpsCanvas wanted to take LLMs and make them be as knowledgeable as, a cloud ops engineer. Like, what are the things that would be additive to that? That the power of the LLM. We just talked about context graph. Is there anything else that an agent would want to have or know or be skilled at that would be important?
Well, surely having access, so building the context graph is a very important piece of that. And so how, answering that question, how does this context graph get built so that it can be ingested and reasoned over? And that is external to the model itself and external to in some regards, external to the agent itself. We sort of talked about read and write path, but there are other points of data capture besides coming from the agent. So, I mean, those are very big attendant pieces. And then once you start collecting data at scale, you of course have to deal with all of your sort of traditional data collection problems. That's not a model problem. That's a traditional sort of software problem.
Yeah.
How do you handle large data sets? How do you query them effectively? How do you, pay for them
So
effectively, reduce cost?
sorry, we're almost out of
Yeah,
time. Sorry to cut you off, but I just want Ardy to get in because he's our lead AI engineer. How
yeah,
would you
sorry.
think about this? How could an LLM be super powered, supercharged to be a great cloud op or an ops agent?
Yeah, yeah. It it needs the subject matter knowledge. So in CloudOps, it would need, like in AWS, they talk about the well-architected framework. That is some subject matter knowledge that is unique to cloud operations, which can be codified. There are manuals, there are documentations about it, and it needs to be able to access that. It needs to be able to have, as Jason pointed out, have the permissions to actually see through your cloud and figure out, well, what currently exists and why it was the case. Because if it has those two pieces of information, then it can see that, okay, this state of the cloud, is it really achieving my intended goal? If not, then we can make some change to it. We can maybe right size it. We can maybe escalate it to the human, ask whether it's really needed anymore. And by the way, all these decisions that it makes, it should be placed somewhere. We would say in a context graph, such that the next agent or my agent or some other employee's agent can traverse that reasoning process, so that alluding to those LinkedIn posts, I do remember seeing one of those LinkedIn posts in which somebody was saying that they reduced their bill so much by changing the CPU size to something and whatnot. And they did so many, and like Cloud Code, right? It's gonna take actions real quick, and it's gonna give you this immediate feedback. In a course of like 10 minutes, you'll have made like 100 tool calls and changed whatnot. And then all of that decisions that were made in concert with Cloud Code, they're only recorded in the LinkedIn post. Like, I mean, that's not a durable model. Like the next time tomorrow, somebody will be like, hey, how did the CPU change overnight? What happened here? And so yeah, you don't want to be like going back into CloudTrail and trying to figure out, that's just more work, right? So for the
Yeah.
human. And so yeah, I think it
That's
needs to be durable. Yeah.
that is a great way to end things. I like what you said. That's the work that a human doesn't necessarily want to do, and it's not durable. So I think when we think about context graphs is about durability of institutional knowledge. I think that it's also obviously about trying to find where it can help humans make better decisions, but ultimately also enable AI and agents to be not just making better decisions, but contributor to the team. So we really, appreciate everyone joining us. My apologies for going a few minutes over, but it was such a fascinating conversation. I didn't want to end. And so thanks, Ari, for hosting and organizing the webinar. Big shout out to Jason and Ardy for just really incredible insights. And if you'd like to talk more about AI or context graphs, please reach out. We're happy to schedule a call to go deeper if anyone wants to just spitball and see how it might apply to your organization. This was one webinar in a series that we're doing this year, talking and discussing the challenges and opportunities of AI and cloud operations. So take care. We look forward to seeing you again next time. And thank you very much.
Thanks, everyone.
Thank you. It was a pleasure.